As lessons on 6.1 and 6.2, an overview of relations and relationships of functions. There are three ways to determine whether a relation is a function. So the first method is called a mapping, and we're going to check it out to see if the relation is a function. So as you can see, the two different ovals, the first oval, it represents the input, also known as the x, and the second oval represents the output, also known as the y. In the input of 12, notice that there is an arrow pointing to the output of 6. In the input of 23, notice there is an output of 15. And in the input of 30, there is an output of 20. And then the input of 48, there's an output of 13. So each of those inputs have to have one of the outputs. So let's make a note of this. The note is that each input has exactly one output. Therefore, the relation is a function. So in this case, we are going to say, yes, this is a function. And it's only because each of those has only one output as stated below. Now let's look at an example that is different. So in this example here, we're asked the question, is the relation a function? So if you look at the input of x of 10, notice that the output has a 0 and a 1. And then the input of 11 has an output of 0, which is fine. But the input of 12 has an output of 1 and 3. And then the input of 13 has an output of 2. So as stated in the note, that each input has exactly one output. In this case, because 10 right here has an output of 0 and 1 together right here, and then the other one, which was the 12, has the output of 1 and 3. So because each of those inputs have more than one, this is not a function. So this is going to be no on the function. So that's one method, which is the mapping, that you'll see inputs, outputs, and arrows drawn to the outputs to show that. What happens is also on the output and also on the input, notice that they are numerically in order, and that's why it's drawn with the arrows on that. Now let's talk about is method number 2. So method number 2, we've actually seen this in previous chapter, and that is the table. So the table method is also another way to see if this is a function or not. And so when we have an input and output, same thing as the previous one, the mapping. In this case, we actually have to solve for the output. Whereas the mapping, they give us the input and output numbers and then also the arrows, and just have to see if it's a function relation or not. So in this case, let's go ahead and substitute our numbers, the input, into the equation and then see what the output looks like. So if I substitute in -1 here, -2 times -1 is going to give us +2. +2 plus 1 is going to give us 3. If I substitute 0 into the x right here, -2 times 0 is 0, plus 1 will give us 1. When I substitute in 1, -2 times 1 is -2, and -2 plus 1 is -1. Now if I substitute 2 in there, -2 times 2 is -4. -4 plus 1 is -3. So now we have the output similar to the mapping portion of it. But in this case, there's no arrows because the input of -1, the output is +3. The input of 0, the output is +1. And the input of 1, output is -1. And the input of 2 is -3. Now we can also put this in order pair, as we have done in previous chapter. So the x is -1, comma, y is 3, and the order pair for this one would be x is 0, y is 1, and the order pair for the third set would be 1, comma, (-1), and the last one would be 2, (-3). So taking these ordered pairs, we go into method number 3, which is then the graphing method, and we're going to graph out those ordered pairs. So when you graph out the ordered pairs, you're going to find when you connect each of those dots, it's going to be a line, just like how we have done in previous chapters. But now in the graphing method, to find if it is a relation is then to do what we call a line test. So when we do a line test, you can visually see if it is a function or not. For the line test, I would take a straight edge and use a pencil or a color pencil and draw a line and see if that line touches the linear line that was drawn from our previous table. So in this case, it touches at one point, which is this point right there. So because there is one X and one Y right there, then we're good for this one so far. And then anywhere on the line, so I can even draw it right here, and then from there, the line where it connects to at this point right here, there's only one X and one Y, and so that looks good so far. And you would just kind of just go through with your straight edge to see if there is only one point and one line. Now you may ask yourself, well, what does it look like if it's not a function? So let's go back to the previous example that we had looked at, which was the input and output, and we had stated that this was not a function relation. And the reason is because if we graph this, so let's graph this out, then you can see it visually why it's not. So for example, the input of 10 is the output of 0 and 1. So at 10, I'm going to go ahead and put a dot at 0 and also put a dot at 1. And then for 11 on the X, we're going to go ahead and put a dot at 0. And for the 12, there are 2 points at 1 and 3. So at 12, there's a dot at 1 and 3. And then at 13, there's a dot at 2. So if we draw a line using a straight edge like we had talked about before, let's say right above 10, you're going to find that it touches 2 points on that. And that point was at 0 on the Y and 1 on the X. Now at 11, we're good because it only touches 1 point right there. But anywhere the relations, if it touches at 2 points, then it is not considered a function. So, and that's why in this relation, it is not a function. So that is the overview of relations and representations of functions.